Let's jump right into this explainer and demystify how we can actually protect our local area networks from internal spoofing threats. When we think of network security, we almost always picture those massive firewalls sitting at the outer edge, right? But what happens when the threat is literally already inside the house? Today, we're going to lock down the absolute foundation of our local networks, Layer 2, using two incredibly powerful features built right into our switches: DHCP Snooping and Dynamic ARP Inspection.
So here's our roadmap for today. We'll start with the rogue DHCP threat, look at how DHCP Snooping works, and run through configuring it. Then we'll pivot over to the gratuitous ARP attack, break down dynamic ARP inspection logic, and finish up with configuring that inspection.
All right, kicking things off with Section 1, the rogue DHCP threat. So, we really need to understand how a completely normal, everyday network process can be weaponized by an attacker sitting just, a few desks down. Just picture this scenario. You plug your laptop into the wall, and it automatically asks for an IP address so you can get to work. Seems fine, right? But what if the device that answers isn't your IT department's legitimate server? What if some rogue device on your network intercepts that request, hands out a totally fake IP address, and cleverly sets itself as your default gateway? Suddenly, every single piece of data you're sending out to the internet is silently flowing right through the attacker's machine. It's a nightmare scenario. Normally, getting an IP address follows the classic four-step sequence we all know, the DORA process: discover, offer, request, and acknowledgement. Your machine sends a discover message, and the real server replies with an offer. Simple. But an attacker can spin up a spurious DHCP server on their laptop. And their main goal here? To race the legitimate server and reply with a malicious offer first. If they win that race, your computer accepts their bad IP config, and boom, they've successfully pulled off a devastating man-in-the-middle attack.
Moving right along to Section 2, how DHCP snooping works.
Now that we see just how easily the standard DORA process can be exploited, let's look at the absolute best shield network engineers have to stop it dead in its tracks. Honestly, think of DHCP snooping as the ultimate bouncer for your network. When you turn this feature on, it strictly separates your switch ports into two distinct categories. First, you've got your trusted interfaces. Think of these as the VIP doors that connect to your real DHCP servers or other trusted switches. Then, you've got your untrusted interfaces. These are just the standard doors where your regular end-user PCs and laptops connect.
The real magic here is the step-by-step logic check the switch starts performing. First up, it examines all incoming DHCP messages. If it sees a server message, like an offer or an ACK, trying to enter an untrusted port, it instantly discards it. The bouncer literally just says, "Nope, servers don't come through this door." Now, for client messages, it strictly validates that the MAC address inside the DHCP Discover payload exactly matches the actual Ethernet frame MAC. It also heavily scrutinizes DHCP release messages just to ensure attackers can't maliciously drop your IP address. And finally, for the good traffic that actually passes all these tests, it builds something highly valuable: a binding table.
What's super interesting about this is the VIP guest list it creates. This is our DHCP snooping binding table. Every single time a legitimate device completes a DHCP lease, the switch safely records the device's MAC address, the IP address it was just assigned, its VLAN, and the exact physical switch port it's connected to. And as we're going to see in just a bit, this dynamic database becomes the absolute bedrock for other security features on our network. All right, Section 3, configuring DHCP snooping. Let's bridge the gap from theory to practice here. It's one thing to talk about a bouncer analogy, but let's see how we actually tell our Layer 2 switches to enforce these rules. Seeing server racks and dense bundles of cables like this really reminds us of an important reality. Applying this Layer 2 security, it happens right at the physical infrastructure level. You are quite literally securing the physical wire connections that devices are using to access your network. It is incredibly foundational. So here are the core commands you drop into a Cisco switch. First, you turn the whole feature on globally with IP DHCP snooping, and then enable it for your specific VLANs. Now remember, by default, all ports are untrusted, so you absolutely have to explicitly configure your server-facing ports with IP DHCP snooping trust. Finally, take a look at that last bullet point.
Translating that syntax to plain English, typing IP DHCP snooping limit rate 10 tells the switch to drop the port into an error-disabled state if it gets hit with more than 10 DHCP messages per second. This is absolutely critical, because attackers might try to overwhelm the switch's CPU with thousands of fake requests, a classic denial-of-service attack, and this rate limit completely neutralizes that tactic.
Let's pivot over to Section 4, the gratuitous ARP attack.
With our DHCP fully secured, let's look at our second major vulnerability. This time, attackers are abusing a completely different protocol, the Address Resolution Protocol, or ARP, to maliciously redirect our local traffic. To really grasp this attack, we have to understand gratuitous ARP. Now, normal ARP works kind of like a roll call, right? A device asks, "Hey, who has this IP address?" And the owner replies, "I do, and here's my MAC address." But a gratuitous ARP, that's an unprompted broadcast. It's a device just shouting out to the whole network, "Hey everyone, update your records, I'm at this IP." Attackers can actually forge these unprompted messages to trick nearby PCs into associating the attacker's MAC address with your router's legitimate IP. And just like that, all your outbound traffic gets sent straight to the attacker.
Which brings us perfectly to Section 5, Dynamic ARP Inspection Logic.
To defeat these spoofed ARP messages and stop this nasty cache poisoning, we have to deploy our second shield. This feature is called Dynamic ARP Inspection, or DAI for short, and watch how these features just build together beautifully. Remember that VIP guest list we talked about a minute ago? DHCP Snooping acts as the bouncer checking IDs at the door to build that precise list, while DAI steps in as the internal security. It uses that exact same list to make sure nobody already inside the network is trying to impersonate someone else.
DA applies some really simple, undeniable, but incredibly powerful logic. When an ARP message arrives on an untrusted port, the switch doesn't just blindly forward it anymore. Nope, it intercepts it, it opens the message, looks at the origin IP and MAC address, and strictly compares them against the DHCP snooping binding table. If it detects a lie, meaning that MAC and IP pair don't match the historical record we saved, the switch immediately discards the frame. The spoofing attempt is literally killed right there on the wire.
Let's wrap up the technical side with Section 6, Configuring Dynamic ARP Inspection.
Okay, let's look at our final configuration steps to actually get this inspection protocol running on our switch interfaces. Honestly, the config mirrors exactly what we just learned with DHCP. We enable DAI on the specific VLAN, and we set our trusted ports, which, by the way, are usually the exact same uplink ports we trusted for DHCP snooping. We also set up rate limits to prevent an attacker from flooding the switch CPU with bogus ARP messages. And lastly, we can configure some optional deep dive checks, telling the switch to validate that the Ethernet frame's source MAC address exactly matches the origin MAC claimed inside the ARP payload. It takes a little extra CPU power for sure, but it is an incredibly thorough validation.
So, the really crucial takeaway we've uncovered today is this. While DHCP snooping and dynamic ARP inspection flawlessly secure your internal Layer 2 network from those local, inside-the-house threats, it leaves us with a pretty massive question to explore next. Once your local connections are completely locked down and spoof-proof, who is actually protecting the outer edge of your network from the rest of the world? It's a fascinating question and absolutely one to keep in the back of your mind as you continue expanding your network security toolkit.